Find the inverse function of f of x equals 2x minus 3. Rewrite that original function there as y equals 2x minus 3. And the first step in solving an inverse is to simply rewrite this equation swapping the roles of x and y. So x is going to get put over here and y is going to get put over here. That means you now have the equation x is equal to 2y minus 3. The next step is to solve this equation for y. So the first step in solving that equation for y is to add 3 to both sides of the equation. When you add 3 to the left-hand side of the equation, you get x plus 3. And when you add 3 to the right-hand side of the equation, you get 2y. Now the next step in solving this equation for y, if you want to isolate y, you should divide both sides of this equation by 2. When you divide the left-hand side by 2, you get x plus 3 divided by 2. And when you divide the right-hand side of the equation by 2, you get y. Well, now that we have y isolated, this function right here is the inverse, and that inverse often gets written f inverse of x is equal to x plus 3 divided by 2. Now, a function and its inverse, in some sense, undo one another. So if you want to work with this a little bit, pick a number x to plug into this function. Let's say 5. So when you take 5 and plug it into this function, you get 2 times 5, which is 10, and 10 minus 3 is 7. So f of 5 equals 7. Now take that same 7 that was f of 5 and plug that into f inverse. Well, 7 plus 3 is 10 divided by 2 is 5. So you can see that the inverse function, f inverse, in some sense undoes the original function f of x. If you want to see this graphically, you can do the following. Here is the horizontal axis x and the vertical axis y. A couple tick marks in every direction. Well, what is this original function here? This is a line with slope 2 and y-intercept negative 3. So here is the y-intercept, which is negative 3. And to get a slope of 2, what that says is you rise 2 and you run 1. So that tells you that this is a second point on the line. 2 points determine a line, and that line looks something like this. And that is the line y equals f of x, which is the original function. Well, what does the inverse function look like? Well, it is x plus 3 divided by 2. That is a line with y-intercept 3 halves. Let's go ahead and label that. 3 halves is right here. And it has a slope of 1/2. And what a slope of 1/2 is you rise 1 and run 2 units. So here is our second point. We go up 1 and over 2, and we get that as the second point on the inverse function. So it can be drawn as the line passing through those 2 points. So now what we have is we have y equals f of x, labeling the first function, and y equals f inverse of x. To put a little more geometry into the picture, we can draw the 45-degree line y is equal to x, and it is going to look something like this. And it turns out that a function, which is right here, and its inverse are simply mirror images across the line y equals x. So that's a long story about finding the inverse of the function f of x equals 2x minus 3.